And I love YouTube.
We're live.
Yeah, we're live. We're good.
Okay, cool.
You gonna start us off?
Yeah, Colt, you start us off.
Okay. The first one's about the pea plants. Is that the one with the F2 wrinkled yellow seeds?
Yeah.
So the first probability that I got was 3/16.
Yep.
And then the next one was 9/16 to the third.
Mhm.
Then C, I got 62.5% because you add them. And for D, I got 43.75.
Okay.
So I got a question for you, because never mind. Okay.
Do you know when, as a general rule, when you add or when you multiply?
Yeah, Brad, do you know?
So you add when it's and you multiply when it's or.
No, switch that.
Yeah, I think so.
So if it's going to be easier to get to, right? So if it's and, then it's more selective, so you multiply.
Well, the chances
No.
of something that's and to happen is
Right.
lower. That's why you
It's
multiply.
going to be harder to get it to happen.
Right.
Right.
So then you multiply.
Mm-hmm.
That's what I thought. I was just making sure that I was with the same program as everybody else.
Yeah,
I was doing for the F1 generation. It's a lot easier if you do the F1 generation.
Yeah.
Like either 0 or 100%. I did that for the first two. So that sucks.
Yeah, usually
But
you're
not a
gonna,
big deal.
to get like the 3/16 and the 9/16 and stuff, you're multiplying still, like kind of like what we've been doing. You're multiplying the chances of getting yellow seeds with the chances of getting wrinkled seeds.
Right. And it's at 9 to 3 to 3 to 1 ratio.
Yep.
Of the 16ths. Yeah. I'm with you.
Okay. Brad, where did you get to on the assignment?
So I got to like number 4D. So I just didn't do number 5.
Okay. Sweet. I'll do number 2. Okay. This is the tall plant, purple flowers, dwarf plant, white flowers. So it says, what's the probability that the first 4 progeny plants produced by the cross are tall and purple? So I just have the answer, but I think this one was 3 out of 4 for the tall and 3 out of 4 for the purple. And so you just do 3 fourths times 3 fourths.
Yeah, that's right.
Raise that to the 4th, and then you get 10%.
That's what I got.
Okay. So B, you get what is the probability that the first 4 offspring are either tall with white flowers or dwarf with white flowers? I got 0.1%. C, what is the probability that if 7 F2 plants produce, 3 are tall with white flowers, 4 are dwarf with white flowers? I got 3.52 times 10 to the negative 4%.
I got 10 to the negative 6.
Did you get that for your percent?
Oh, no, that was the not percent. You're right.
Okay, yeah.
If I times it by percent, it would be negative 4.
Yeah. Good. Following order of phenotypes is observed. Oh yeah, this one you just multiply the probabilities each with what it wants. So one plant is tall and purple and all that. And so I got 9/16 times 1/16 times 3/16 times 9 times 3 equals 0.07%.
Sweet.
Okay, good.
Cool. So, I wasn't 100% sure on this one, but for my null hypothesis, I put if the original plants are true breeding and the genes for being disease sensitive and herbicide resistant are dominant, then we will observe close to a 9 to 3 to 3 to 1 ratio.
Yeah, that's about right. That's just like a different way of saying Mendel's law of segregation.
Sure, yeah.
Yeah, I looked on the slides. That's where I got my null hypothesis. When like the slides say the null hypothesis, Mendel's law of segregation.
So that's where I just copied what it said.
Right on. That was in biostats. We always did them as if-then statements. That's how my teacher wanted them. So then for the B part, I was a little bit confused. It's pretty easy, just plug and chug. And I got 3.69 for my chi-squared value. And then for C, I mean, to get your DF value, you just do 4 minus 1.
Right.
I can't even remember what it's called.
Degrees of
And
freedom.
then degrees of freedom, right. So then, because 3.69 is outside of the range of 3 and to negative 3, we reject the null.
Yeah, I didn't get 3 point whatever.
I didn't either.
What'd you get? I got 0.543.
That's what I got. But wouldn't the chi-squared be different based off of your null hypothesis? But his null is probably the same if you were following Mendel's 9-3-3-1. That's what I put too. So
Yeah. Yeah. So if it's 3 degrees of freedom with 0.543, you're still in that lighter green area, which means that you can't reject the
no.
Null, which is saying it follows Mendel's ratio.
Right.
Okay. Yeah. Still, I'm not like 100%. I really don't understand very well still the idea behind a null hypothesis. I've heard it used in a different way than what this class is like having it be used.
It is different.
And is your chi score, is that your what does that have to do with like probability? Like significance, statistical significance?
I'm not sure statistical significance. Other than we look at it at that chart to decide if our hypothesis is true or not.
And somehow those chart numbers are telling us whether it is.
Because it depends on what you put as dominant or recessive. You can get different chi-squared values.
Right. Okay. I asked her that question. I was wondering how this like related to like if this makes your null hypothesis significant or if it doesn't based off your chi-score. I should go back to it, but anyway.
Can you guys hear me?
Yeah.
Mm-hmm.
What did you guys do to calculate your expected to plug into the chi-squared?
If it's going to follow Mendel's law, then it has to be the 9-3-3-1 ratio. So you add them all up,
times that by 9/16ths, take that number and minus 157. Square it, divide by the number that you calculated, you expected. Does that make sense? And then you do
minus 157.
and then you do 3/16 for 3/16 times your total for the 57 and 54 values, which I think 3/16 times your total is 54, so that one like just kind of works out to just 0. And then you do for the 20, you do 1/16 times the total. Get your expected.
So say that you propose a null and you test it and the try says reject the null. Do you then propose a new null hypothesis and try to figure out when the chi-square does not reject the null?
Yeah, you do an alternative hypothesis to explain, like if this one was rejected, you try and explain why that there was 157, 57, 54, and 20.
And
Meaning, yeah.
is there a pool of like different hypotheses that we could have?
Yeah, you can have like X-linked. I think that one of the questions on here means it. It was kind of cool when I was like researching. I was like, crap, I have no idea, because there is one where you have to explain an alternative. I just Googled. Yeah, it's the last one. So the last one doesn't follow Mendel's 3:1 ratio or whatever.
Right.
It was a 2:1 ratio that I figured out it was a 2:1 ratio, and so I was like, okay. I just Googled what inheritance patterns follow a 2:1 ratio, and it was the lethal inheritance pattern. So I was like, oh, that's probably an alternative hypothesis. Is to test now if this one follows lethal inheritance.
Right. So try to figure out what percentage of each is coming out, I guess.
Yeah.
And then apply
Propose,
that to
like,
what we know.
Yeah. Propose like an alternative test that you can do to explain why the observed results were what they were.
Okay.
Yeah. Which is hard. It's harder. It's obviously way harder.
Yeah,
than
that's
just
really
accepting the
hard.
null.
Well, but I think the idea behind the null hypothesis, and the reason they call it a null hypothesis, is you're not proving it, you're just proving that it follows that. It doesn't necessarily mean, it's not proving causation, it's just proving correlation.
Mm.
And
Yeah,
so,
statistic. Yeah.
right, so just because your ratio matches up doesn't necessarily mean it matches with an inheritance pattern. But if you reject the null hypothesis, at least, and this is, I probably should just keep my mouth shut because I don't really know what I'm talking about. But in my mind, if you reject the null hypothesis, then you need to have some sort of a plan as far as explaining what it is. So you don't even necessarily have to test your alternate hypothesis, right? I mean, in a research setting, you will, because that's where you're going to get money. Is when you. I mean, if you're just rejecting all your ideas, it's not any good. But once you can say, we've found some correlation, that's when you can start making the money. So, in my mind, the reason, if you fail to reject the null, that's a big thumbs up. If you reject it, you have to come up with a different way of explaining the phenomenon that you see. I don't know if that helps or hurts, or I just need to get my voice on this video on YouTube. That's what I'm trying to do.
Yeah. No, that was good. Good stuff.
That was really good. Now that makes better sense, actually.
Yeah, that is good.
Let me do the next one because I think I know it.
Okay.
Okay, 4A. I don't want to do all of them, just A. So you can see in the one generation that it's going from male to female, so you know it's not Y-linked. You can see it pass from male to male, so you know it's not X-linked. So if it's not X-linked, it's not Y-linked, it's got to be an autosomal disorder. And if you come down, you can see as it goes through that it's dominant. I can't remember what my reasoning was, why I put autosomal dominant, but that's what I put.
Because it doesn't skip a generation.
Yeah, recessive skip.
Yeah, because it doesn't skip a generation. Exactly.
Okay, I have a hypothetical one for you guys that I need to confirm because I've heard it before, but it wasn't on her slide. So, if a trait is X-linked recessive, and you have an affected mother, all of her sons will be affected, right?
True.
Yeah.
Because they're going to get their X in a month.
Good. Okay, move on.
Okay. B. This one is obviously dominant because it doesn't skip. And in our Bio 181 class, our teacher always said that if the father always passes it to daughters, then you know that it's an X-linked trait. And so in this case, you can see in two scenarios that the father is exclusively passing it to daughters and none of his sons. So I put X-linked dominant.
Okay, that's what I put too.
I put that, believe it or not.
Okay, C, I put that it's X-linked recessive because it does skip a generation.
That's right.
That's what I put.
That's what I put too.
Yeah.
Okay, D. It's recessive because it skips, and doesn't seem like there's any inheritance pattern, so I just put autosomal. Recessive.
Yeah. Yeah, usually when I'm doing autosomal recessive, I have to just kind of maybe eliminate them.
Yeah, that's the best way for me too.
This one took a while. 5.
Yeah.
Well, I'm happy I didn't get there yet.
Go for it, Colt.
So, A, my chi-squared was 1.257. But I noticed that it's wrong because I went over the answer key. Because I was like, I don't even know if I'm doing this right. So I didn't want to just sit and do the math. So I figured out that if you have to round when you do your ratios, like when you multiply 9 divided by 16 or whatever you're doing. In this case, it was 3 to 1. So yeah, so fourths. You can get like 273.75 or whatever, but you round up because you can't have 7.75 of a person or whatever, or you round down. And then I think it's right if you do it that way.
Did you were you pretty close though, Colton?
Yeah, it was like around I don't remember what the actual answer was. I think it was like 1 point something. What did you get, Patrick?
That's what I got. I got 1.257, and it's because I didn't round, but that's what I was figuring is because I wasn't rounding, and so I was getting a 1. I think
yeah. So the answer says
lower.
1.188.
Yeah.
But then,
I
yeah,
don't
I
know.
did round it and I tried it and it worked. To her answer, at least.
I
did.
feel like, because when you're dealing with like the p-value and rejecting the null and that kind of thing, I feel like, and I can understand what she's saying with you can't have half a person or whatever, but that's not, I mean, you're dealing with ratios and that kind of thing anyway, so at the end of the day, you're going to be looking at thousands of people, you know what I mean? You're not looking at one person or percentages or whatever.
I wouldn't round if I was doing it, but
I feel like though you should be able to get, like, if you were on the edge and you don't round, your answer is going to be more accurate as far as rejecting the null or not rejecting the null.
Right.
Does that make sense?
Yeah.
Like if you
Yeah, that
round
does.
it and it changes whether you reject or you fail to reject, in my mind that's a problem. Like you shouldn't round and count that as your hard answer. Your hard answer should be unrounded. And then if you want to make it more practical or more applicable, that's, I mean, you can do whatever you want, but at the end of the day, your real answer for a p-value, which is, right, the whole basis of whether our data is good enough, I don't know. And that's just, I guess,
Don't round.
I guess that's just the opinion. It doesn't really matter.
If you don't round or if you do round, it's not going to change whether or not you reject or not because the value is so close anyway.
yeah. So then
That's my point.
so that one, either way, you would fail to reject.
Right. Yeah.
And then the
And
next
it's
one,
So on this one, it's the same thing though, because there's 4 phenotypes. So our DF is 3.
Mm-hmm.
yeah.
Cool. Okay.
Or actually, no, the F is
1.
1 because you have 2 phenotypes.
Yeah, only 2 phenotypes.
Right. Okay. Yeah.
Because it's
Yeah.
either gray or yellow. So on B, I got 68.83, which is like huge. I thought I was wrong, but you're gonna reject the null big time. And C, I got similar. I got 61.28 and reject the null again. So I said that in bigger studies with bigger samples, you rejected the null. So obviously the Mendel inheritance is not right. Because didn't it say something about how the bigger your study is, the more precise you're going to be? So the data from the bigger ones is going to be better than that little one.
Yeah. I did read the packet. I just didn't do the homework. And that's, I don't know. You guys have done biostats too, whatever. So I should, again, just keep my mouth shut. But when we were doing mine, our alternate hypothesis, like, sometimes our alternate hypothesis was that it doesn't follow the Mendel. Like, for this, it would be that it doesn't follow the Mendelian pattern for inheritance.
Yeah.
You know, and I think on this question she wants us, like Pat did, she wants us to kind of go out and look for what it is. But at the end of the day, I think if you're looking technically for an alternate hypothesis, like it just has to be something that attempts to explain the phenomenon you saw.
Right.
Yeah. Sweet.
That's it. That's it.
Yeah. Anybody else have any questions we can discuss?
I already did the.
Of course you
homework
did.
for Personal.
I did half of that one.
Oh, of course you did.
It took me a while.
It takes a long time.
Yeah. So I'll plan for that.
I got up at 5:30 this morning to do it and remembered I had religion stuff I had to do or I wasn't going to get credit for being there today, and then I worked after class until right now. So, as pathetic as it is, that's my excuses. I should have been sitting out front of Brolum's, and I wasn't. I've got to write a personal statement. I've got to get my letters of recommendation done. And I've got to call and figure out the transcripts that I sent in, if I need them or not, to the AAMC. So I'm not sure when I'm going to do all that. And I've also got 3 tests in the next 2 days. And then work all day Saturday. So, yeah. I might need to go get some Red Bull.
Yeah.
Anyway,
So I won't see
I'm
you
sure
in
you
class
guys are
tomorrow.
in the same boat.
I don't have to write a personal statement.
I don't have twins in the hospital, so that's nice.
Yeah.
Consider yourself lucky there. Or unlucky. Actually, yeah, you're unlucky. Okay.
Alrighty. I'll post it.
Brad, good
Okay.
luck with that. I'll see you in class tomorrow.
Hey, thanks.
See
You
you
boys
guys.
have a good night.
Okay, you too. Thanks for recording, Colt.
Yeah.
Yeah.
Later.